Okay, today we're going to be looking at Unit 2, Topic 3, questions 40 through 41. So I'm going to do a few of these multiple choice questions on the same video. All right, question 40. Look at the system of equations below. We have y equals mx plus b and y equals 6x plus 15. Well, hopefully we recognize y equals mx plus b is the slope-intercept formula for a line. Okay, so we know that m is our slope and b is our y-intercept. So we need to know that first. Okay, so we know that this second equation here has a slope of 6 and a y-intercept of 15. Important information there. All right, let's look at our options. We have a multiple choice. Which of the following statements are true? Okay, so we want are true. All of the statements below are true. Okay, well, let's read the statements below. If m equals 6 and b does not equal 15, then the lines are parallel and there's no solution to the system. Okay, so we have to define a couple of things. So let's look at the possibilities. Our options are going to be, are the lines parallel? Do they intersect, or are the lines the same? So let's actually go over that really quickly before we answer the rest of this question. I'm going to make a little chart here. So we're looking at parallel lines, intersecting lines, or the same line. All right, so when we look at two equations, we can actually tell just from looking same lines. Why am I writing like this? Okay. Just by looking at the equations, whether or not they are parallel, intersecting, or the same. Okay, so parallel lines have the same slope, but different y-intercepts, or b-values. Okay, intersecting lines will have, the slope actually doesn't matter as much. You can, excuse me, we're going to have a different slope. And the y-intercept is what doesn't matter. So we just have to have a different slope. And the same lines will have a same slope and the same b-value. Okay, so I'm going to say that one more time. Parallel lines have the same slope and different b-values. Intersecting lines have a different slope and the b-value doesn't matter. And the same lines will have the same slope and the same b-value. So that'll help us answer this question. All right, let's go back. So part B, if m equals 6 and b does not equal 15, then the lines are parallel. So let's see what happened. That means that we have the same slope, right? And a different b. And sure enough, that means that the lines are parallel, so we know that that statement is true. Okay. Option C, if m does not equal 6, so that means we have a different slope, then the lines intersect and there is one solution. I'm actually going to add that intersecting lines have one solution. Let's make a note of that. And so that is also going to be true. That means that they intersect at a point, and that point is the solution. And D is going to be if m equals 6 and b equals 15, the lines are the same. And yes, that's what we figured out. So it is going to be option A for this one. All of the statements below are true. If you didn't know that, write those notes down. Study that. It could be helpful for you on the exam. All right, let's go to question 41. All right, so we're Unit 2, Topic 3, Question 41. Look at the system of equations below. So we have two linear equations, okay, and we want to figure out how many solutions they have. So I'm actually going to make another little T chart here for this question with our parallel lines, intersecting lines, and the same line. All right, I'm going to write those notes again for us. So parallel lines, we said they had the same slope, different b values or y-intercepts, and they're going to have zero solutions. Parallel lines will never intersect. They're going to look like this. And so if they keep going on and on forever in the same direction, there's never going to be a point where those two lines are going to cross each other or intersect. All right, we said intersecting lines have a different slope. They must have a different slope. The b value doesn't matter. And if they intersect, they're going to have one solution. And our intersecting lines are going to look something like that. There's going to be some point where they intersect. Same lines are going to have the same slope. Everything is going to be the same. That makes sense, right? Same b. And what's going to happen, if I go to graph those, I'm going to graph one line, and then I'll end up graphing the exact same line again. So they would be directly on top of each other. Okay, so let's look at our choices and our equations here again. All right, so the first equation, I'm going to identify the slope and the y-intercept. So we have a slope of 4 over 5, that's our rise over run, and a b value of 7. And this one's going to have a slope of 3 over 4 and a b value of 7. So what I noticed right away is that these two lines have a different slope. The only option for that is going to be right here, our intersecting line. So when we have a different slope, we know that they're going to intersect and that there will be one solution. Okay, so the correct answer for 41 is going to be B. Let's move on to 42. All right, look at the systems of equations below. What is the y-coordinate of the solution to the system of equations? All right, so we're actually going to solve this system of equations. I'm going to do that using the method called substitution. All right. Okay, the easiest way to use substitution is look for the variable that is by itself. So I noticed that x is by itself for this top equation. And so what I'm going to do is I'm going to get everything else away from it. So I'm going to do that right here. We have x plus 5y equals 27. And I'm going to isolate x here. So I'm going to say x equals 27 minus 5y. Now that we've solved for x, we're going to take the right side of that equation and we're going to put that expression into the x value of our second equation. That's why we call it substitution. So let's do that. We had x plus 3y equals 21, but we know that x is equal to 27 minus 5y. So let's write that. 27 minus 5y plus 3y equals 21. And we're going to simplify and eventually solve for y. So I'm looking for like terms here. So I notice minus 5y plus 3y. That's going to give us a total of negative 2y. I'm going to try to get my numbers to the other side here. So I'm going to subtract 27 from both sides. And I get negative 2y is equal to negative 6. And that's going to give us a y value of 3. And the question asked for the y-coordinate. So we've answered this question. Y is equal to 3. That's going to do it for questions 40, 41, and 42.